Good day, Math Buddies! Sir Sherwin here, your math instructor. For today's video, we will be learning all about arithmetic sequence, arithmetic mean, and arithmetic series. Of course, we will be guided with these objectives. First, define arithmetic sequence, series, and mean. Find the nth term of an arithmetic sequence. And derive the formula to find the sum of the n terms of an arithmetic sequence. Arithmetic sequence or arithmetic progression is a sequence where each term is formed by adding a constant d to the previous term to get the next term. The constant d is called the common difference. The nth term of an arithmetic sequence is given by a sub n is equal to a sub 1 plus quantity n minus 1 times d, where a sub n is the nth term or last term, a sub 1 is the first term, n is the number of terms, and d is the common difference. Let's have our first example. Ariel's monthly allowance increases by 600 pesos every 3 months. If he receives 3,000 pesos on May, how much will be his allowance be in February the following year? Note, there are 10 months from May to February. Ariel's allowance increases every 3 months. His allowance must have increased 4 times. This would be the solution. A sub 1 is equal to 3,000, n is equal to 4, and the common difference is 600. Using the values given, substitute this in our arithmetic sequence formula. A sub n is equal to a sub 1 plus quantity n minus 1 d. By substitution, we have a sub n is equal to 3,000 plus quantity 4 minus 1 times 600. Simplify, a sub n is equal to 3,000 plus 3 times 600. A sub n is equal to 3,000 plus 1,800. Combine these two, the sum is 4,800. Therefore, we can say in February, Ariel's allowance is 4,800 pesos. Let's have the second example. The fourth term of an arithmetic sequence is 12, and sixth term is 18. Fill in the missing terms. For our solution, let's assume a sub 1 is equal to 12, and a sub n is equal to 18. To determine the common difference, let's solve for d. A sub n is equal to a sub 1 plus quantity n minus 1 d. Our a sub n is 18, a sub 1 is 12, our n is 3, and of course we are solving for d. Simplify, 18 is equal to 12 plus 2d. Then, we need to get rid of positive 12 on the right side and transpose it to the left side using subtraction property of equality. Simplify. 18 minus 12, we have 6 equals 2d. Because we are solving for the common difference, we need to divide both sides by 2. Therefore, the answer is 3. So in this case, we can directly subtract 3 from our last term, which is 18. That means 18 minus 3, the difference is 15. To get the value of our third term, we will subtract 3 from 12. So 12 minus 3, we have 9. 9 minus 3, that is 6. And 6 minus 3, that would be 3. Therefore, our missing terms are 3, 6, 9, and 15. Of course, if we are to solve our terms using arithmetic sequence, all we need to do is to determine the values of our a sub 1, a sub 2, a sub 3, and a sub 5. So, first, let us solve for a sub 1. A sub n is equal to a sub 1 plus quantity n minus 1 times d. So, a sub n here is 18. A sub 1 is unknown. The number of terms is 6 and the common difference is 3. So, we will simplify. So, 18 is equal to a sub 1 plus 5 times 3. 5 times 3, the product is 15. So, we need to get rid of 15 and transpose it to the left side using subtraction property of equality. 18 minus 15, the result is 3. Therefore, our a sub 1 is 3. So to get the value of our a sub 2, add our first term by 3. So 3 plus 3, that is 6. 6 plus 3, that is 9. Of course, 9 plus 3, that is 12. And 12 plus 3, we have 15. The unknown terms in this sequence are 3, 6, 9, and 15. Let's have our next example. Find the 20th term of arithmetic sequence 5, 7, 9, 11, ellipsis. So what would be our solution? Again, utilizing the formula for our arithmetic sequence, let us first identify our first term. In this example, first term is 5. The number of terms would be 20 because we are looking for the 20th term of our sequence. And the common difference is 2. So using the values obtained, substitute this in our arithmetic sequence. So a sub n, that is a sub 20, equals 5, the value of our a sub 1, plus quantity, n is 20 minus 1 times the common difference, which is 2. Simplify. A sub 20 is equal to 5 plus 19 times 2. Then, 19 times 2, that is 38. The sum of 38 and 5 is 43. Therefore, the 20th term of our arithmetic sequence is 43. If we are to write these terms to prove if our answer is correct, this must be 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, 25, 27, 29, 31, 33, 35, 37, 39, 41, and the 20th term is 43. Another example. In the arithmetic sequence, negative 6, negative 3, 0, 3, ellipsis, what term is 48? In this example, we are asked what certain term 48 will be placed in this sequence. So for our solution, we will solve for n. Utilizing our arithmetic sequence formula, our last term is 48, our first term is negative 6, n is unknown, while the common difference is 3. So let us simplify. Let's combine negative 6 and negative 3 on the right side of our equation. That is 48 equals 3n minus 9. Add both sides by 9. Simplify 48 and 9, that is 57, equals 3n. Because we are solving for n, we will divide both sides by 3. Therefore, our n is equal to 19. Therefore, 48 is the 19th term in the arithmetic sequence. Let us also discuss arithmetic series. Arithmetic series is the sum of the terms of an arithmetic sequence. The sum of the n terms of an arithmetic sequence is given by s sub n is equal to n over 2 times quantity a sub 1 plus a sub n, with the condition if a sub n is given. Another formula is s sub n is equal to n over 2 times quantity 2a sub 1 plus quantity n minus 1 times d. So we can utilize this formula if a sub n is not given. Here, we must remember that s sub n is the partial sum, a sub n is the nth term, a sub 1 is the first term, and d is the common difference of our sequence. Let's have our example. If a business firm offers monthly starting salary of 20,000 pesos and an increase of 150 pesos per month, what is the total salaries for 2 years? So what would be our solution? Again, in this case, our nth term is unknown. We will utilize our second formula, and that is s sub n is equal to n over 2 times quantity 2a sub 1 plus quantity n minus 1 times d. A sub 1 here is 20,000, n is equal to 24, and the common difference is 150. So to determine our sum of our sequence, n is 24 divided by 2 times the quantity 2 times our first term, which is 20,000, plus quantity 24 minus 1 times 150. Let us simplify. S sub n is equal to 12 times 40,000. It is the result of 2 times 20,000 plus 23. 23 is difference of 24 and 1. Copy 150. Simplify again. S sub n is equal to 12 times 40,000 plus 3,450, which is a product of 23 and 150. S sub n is equal to 12 times 43,450, which is a result of the sum of 40,000 and 3,450. S sub n is equal to 521,400. Therefore, the total money that will be earned in 2 years in this business firm is 521,400 pesos. Let us have another example. A pile of blocks has 20 blocks in the bottom row, 19 blocks in the second, 18 in the third, and so on, to 9 blocks in the top row. How many blocks are in the pile? So we will utilize the formula S sub n is equal to n over 2 times quantity a sub 1 plus a sub n because our last term here is given. Since there are 20 blocks in the bottom row and each succeeding row has one fewer block until the top row with 9 blocks, then there must be 20 minus 9 plus 1 equals 12 rows. This would be the possible picture of the pile of blocks. So let us substitute. N here is 12, a sub 1 here is 20, and last term is 9. Simplify. S sub n is equal to 6 times 29. S sub n is equal to 174. Therefore, we can say that there are 174 blocks in the pile. This time, let's define arithmetic means. These are the terms between two non-consecutive terms of an arithmetic sequence. In the arithmetic sequence 1, 2, 3, 4, 5, the terms 2, 3, 4 are 3 arithmetic means between 1 and 5. Let's have our example. Insert 2 arithmetic means between 1 and negative 14. So our task is to complete this sequence by filling in the terms as arithmetic means of 1 and negative 14. So here, we will utilize our given a sub 1 equals 1, our a sub 4 which is negative 14, and of course, the number of terms which is 4. So in order for us to solve for D, we will utilize the formula for arithmetic sequence. And thus given, our last term is negative 14, our first term is 1, number of terms is 4, and unknown is D. So simplify, negative 14 is equal to 1 plus 3D. Get rid of 1 by using subtraction property of equality. Simplifying it, we have negative 15 equals 3D. Dividing both sides by 3, the common difference is negative 5. So here, to complete our terms, 1 plus the common difference, which is negative 5, we have negative 4. That means our second term is negative 4. And negative 4 plus our common difference, which is negative 5, it's negative 9. Third term is negative 9. Another example, insert 3 arithmetic means between 10 and 30. If we are to fill in arithmetic means of a sequence that is in odd terms, this would be the idea we need to remember. Just get the sum of first and last term, then divide it by 2. That means 10 plus 30 divided by 2, that is 40 divided by 2. Third term is 20. And if we are to get the second term, just simply add 10 and 20 divided by 2. So 30 divided by 2, the result is 15. And 15 is our second term. And for us to get the fourth term, just add 20 and 30 divided by 2. The result is 25. Therefore, the fourth term is 25. There you have it. Hope you learned something new today. God bless.